A scale factor is the ratio between two similar figures. And so we're given down below two triangles that are similar to each other. We don't need to prove that. We will eventually. But for now, they're just telling us these two triangles are similar to each other. So what I want to do is find a scale factor. To do that, we're going to need to find two corresponding sides that match up and both have numbers on them. What I mean, for example, is that this side here corresponds to this side over here. However, those won't help us to find a scale factor because they both don't have numbers on them. Instead, the two sides that correspond and both have numbers are this top side here and that top side there. They're definitely not congruent to each other. They're not the same length. However, we're told that these two triangles are similar, so there should be a scale factor. To do this then, all we're going to do is set up that ratio. I'm going to use SF for scale factor, and it doesn't really matter which order these go in, but once you pick an order, you'll see that that will affect things later on, and things must be in this order. So I'm just going to go 8 over 10, the left triangle to the right triangle. However, that scale factor is wrong because I have to make sure that I always simplify. So 8 over 10 simplifies to 4/5. The scale factor between these two triangles is 4/5. One of them is 4/5 the size of the other one. Okay, there was one more part to this question, and that was once we found our scale factor, let's go ahead and find the value of all the variables. And so to do that, we're going to use proportions. Let's stick with the scale factor we just found, 4 over 5, and let's use that to find what side x is going to be. It doesn't matter if you find x or y first, but we'll go x first. Notice where x is located. It's over here. That corresponds to this side 4 on the smaller triangle, the one on the left. And so I know the second part of this proportion needs to be either 4 over x or x over 4. The question is, does it matter? And the answer is yes, it absolutely does. This 4, or what's simplified from that 8, came from the left triangle, and we chose to put that on top, although we could have done it differently. That 5, or originally the 10, came from the right triangle. And so we have to make sure that the second part of our proportion is matched up to this. The 4 is on the right triangle, and the x, on the left triangle, and the x is on the right triangle. So we have to make sure this is in the same order, left to right, for top to bottom. At this point, you could use proportions like we talked about in the last video, or let me start to show you some tricks about other ways to solve these problems. Notice both of these had a 4 in the top. Well, if the fractions are going to end up the same, that means the bottom number, the denominator, must match up as well. And so without doing any work, I know that x has to be 5. If you don't believe me, go ahead and cross multiply and divide, and you'll see that, yeah, it is 5. Okay? Let's use another proportion to find y. Start out with your same scale factor. That 4/5 worked so well last time. So this time, let's find y. So I can see in my diagram that y, that side matched up to this side 15. Again, I got to figure out, am I doing y over 15 or 15 over y? And it does matter. Since I chose the left triangle to be on top, I have to be consistent with that. So in this case, y will go on top and 15 goes on the bottom. Once again, you can cross multiply and divide to find your answer, or here's another trick. This doesn't always work, but what's convenient about this one is I know that to go from 5 to 15, I know I multiply by 3. And so since I did that on the bottom, I've got to make sure I do the same thing on the top. So multiply 4 times 3 to get y equal to 12. Again, that trick doesn't always work, but it's a definite alternative to using cross multiplication to solve proportions. And finally, here's one more type of proportion problem you may see. This time it involves overlapping triangles, and so we may need to add or subtract pieces, but that shouldn't be too bad to do. Right now they've given us what is proportional. They've given us this proportion to use up top. Later on in this chapter, we're going to have to write our own proportions. So let's use what they've given us and just plug in some information to see if we can find the missing piece. So they tell us that piece XW, which I know that piece is 12. And the ratio, the comparison to side XV, which I don't know, but if I add those two pieces together, I can see that XV is just going to be 17. So that's what I mean by sometimes we'll have to add or subtract, in some cases, pieces together. I'm going to put that equal to side YW, which is this side down here. Again, I know what that piece is, that's 24, over side ZV, which is this side down here. I don't know it, so I'm going to call that X, even though there's already an X in the diagram. I'm going to call that x for my missing side. So there's the proportion I want to use. Using what they've told us, I've just plugged in the information. Let's solve this proportion. You can cross multiply and divide, or if you like that trick I just showed you, look, it works out well for this one too. It doesn't always work. The numbers have to be nice numbers, but in this case, I know that to go from 12 to 24, all I do is double it. I multiply it by 2. So I'd have to do the same thing on the bottom to get this proportion to work out. So multiplying 17 by 2 gets me an x value of 34. If you don't believe me that that works, go ahead and use a proportion, cross multiply and divide, or I'm sorry, solve the proportion by cross multiplying and then dividing, and you'll see that, yeah, x is 34. That, or I guess I should say ZV, the segment ZV is 34.